In machine learning, model building success depends upon how you utilize your historical data for your model training, model evaluation, and for model testing purpose. Because historical data is the only asset we have for my machine learning process. And if we use the entire historical data only for model training, okay, then we will not have any mechanism through which we can evaluate how well my model is behaving against the unseen data. But that's the actual aim of my machine learning model. We need to implement that machine learning model in the live environment or in my production environment so that it can produce the desired result based on the unseen data, right? Because the real world environment is dynamic, and we need to make sure that whatever model we are delivering in production is able to provide the desired business value. Because if that's not the case, the entire effort which you will spend on building machine learning model will be useless, right? So that's the reason we need to think carefully about how we can split our historical data in different parts. So here in this diagram, I have divided the data in train, validation, and test split. And the purpose for keeping the historical data in three different split is bit different. And we'll see what are those differences are, right? So that we can have some understanding about why we need to split the historical data into multiple parts, right? So in train part, we will use the train split only for model training purpose. So whatever model we would be building or training, it will only use the train part of the historical data, right? So whatever split we have done using any mechanism, we will use only train split. The other split we have called validation split. So the purpose of validation is split is to make sure that whatever model we have built can be evaluated against the unseen data, and the unseen data can come from my validation split, right? Because here you need to remember one thing: don't use validation data for validation data or test data for any sort of training activities, right? Because if due to some reason my training process will look into the validation or test split, the the performance or the evaluation against the validation and test data would be biased, because my training pipeline has looked into those validation and test data, and that will not fulfill the actual requirement. So the actual requirement is to deliver the machine learning model so that it can predict the desired outcome based on the unseen data. So we need to keep these two data set completely separate and use validation data only to evaluate the training pipeline, right? And this will go in loop, right? So this will go in loop. So it might happen that in the first iteration you have trained some model, you have evaluated against the validation data, and you found that something is not correct, and probably you will go to your training pipeline again, and you will modify something in that process, and then it will again go to my validation. You'll find something is not correct, you'll again go to training. So this loop would continue, right? So that's the purpose of validation data. So you can evaluate how my model training is behaving, right? And the third split we have is called test. And the purpose of test is to make sure that before deploying any changes to production, we are judging the actual performance of my trained model against the unseen data, right? And here one thing is very important between validation and test split, because validation is also categorized as unseen data, and my model training hasn't included any part of the validation data, and test data is also fall under the unseen category, right? And my training pipeline has not looked into the test data. But here one very important thing is that validation data has been used multiple times my training evaluation cycle, right? So in some way I have looked into my validation data to improve the performance of my model, right? But test we haven't looked, and this data would be used only once in entire cycle. So say for example, if we are confident that the outcome coming as a part of validation data is good, and we are good to implement in production, and just before implementing that change in production, we performed our evaluation against the test data, and the performance was not very good. So in that case we need to stop implementing that changes to production, and we need to go back to the training cycle again, training and evaluation cycle again. And in the second iteration, don't use the same test data which we had used initially for judging our model performance. So that's the key. Don't look test data multiple times. Otherwise, it will fail the purpose of validation and test split. Okay. And the other key important thing between validation and test data is that validation and test data should come from the same distribution. So what it means that test data should actually resemble my production data. Okay. So whatever data we are expecting as a part of live traffic should come as a part of test data. I mean, those distributions should be reflected within your test data, and similar distributions should be reflected in your validation data, right? Because if that's not the case, then probably the performance against the test data will not be accurate, because we have built and evaluated my model performance against the incorrect split, because my validation data does not reflect the actual production data distribution, right? So that's the critical thing. You need to make sure that it comes from the same distribution. Same distribution means it reflects the actual production data. Okay. And yeah, I mean, these are the two differences you need to remember. Validation data and test data both falls under the unseen data category, but validation data has been used multiple times, and test data should be used only once in my entire model building phase, right? For the next iteration, don't use the same test data for your evaluation purpose. Okay, that's it for now. Thank you.